avez à droite nos speakers distants. Good evening, everyone in this nice ISEP amphitheater, and also distant online everywhere. So it's a pleasure to welcome you to this EREST AHTI conference. And I have to say that it's a new, we have two new features this evening. At first, it's the first time at EREST that we are organizing a conference in English, even if, don't worry, a Q&A session will be possible either in French or in English. But we have some English-speaking high-level speakers either in the room or distant. So it's the reason why it's an international conference. And second, it's the first time we are making this hybrid mode. We are organized with hybrid mode, which is not so easy, and this is the reason why we are helped here by our VL Media colleagues for video and broadcasting. I have just here to thank also my partner, AHTI, Association for History of Telecoms and Data Computing. This is an opportunity to have this EREST AHTI partnership this evening, so this is nice. I have to thank our partners and sponsors here. So at first, ISEP, the Digital Engineering School, with whom represented by Lionel Trochman, with whom and also Carole Irigoyen and colleagues, with whom we have been partnering for many years now, and this is not the first time we have nice conferences in this room. We have also Nokia as a partner, with not only high-level speakers but also participation as a funder of the cocktail reception after the conference, and also Orange, last but not least, my former mother company, with also high-level speaker and also covering the VL Media resources. So it's a particular thank to them. Just a last word to say that this evening we have 10 high-level speakers, 10, 11 high-level speakers, so the timing will be very tight, and as a moderator, co-moderator, I will be obliged to be a bit strict on the timing of our speakers, in order we might have the time in the second phase to have Q&A session. At first, some questions asked by the organization team, and second in the room. Just to thank also, in addition to Philippe, our organization team members, Marc-Antoine Dupuis, Director Business Development at Genesis, Dominique Balbi, Senior Manager Orange Research, Rémi Thomas, Senior Advisor, Senior Technical Advisor at Orange. We have also Marie-Michel Vassiliou at EREST for back office support. So a thank to them. So I pass the floor to Philippe Picard.
Thank you, Jean-Pierre. So I am very happy that AHTI could be associated with this event. I must say that EREST and AHTI have a long past together. We share the same office until we had to move away. In 2006, we had organized a session related to history of mobile in France. And we had several speakers, including Philippe Dupuis, who in 2018 was awarded with Thomas Hoog. He had the James Clerk Maxwell IEEE Medal for the contribution to GSM standardization. Philippe passed in 2019. So his son, who is here, Marc-Antoine Dupuis, contacted me to celebrate the 30th anniversary of GSM. And I consider that IREST could be the best partner. And I called Jean-Pierre because I knew that he was quite implicated in the mobile history with 3GPP. And so that's why we are here. Thank you very much.
Thank you. Well, as I said, Jean-Pierre, I'm representing ISEP, people who are hosting you in this very great event, at the name of Dieudonné Aboud, General Director of ISEP, and also everyone from ISEP who will participate to the organization. I'm wishing you the best, warmest welcome. I'm pretty sure that it will be one of the best events since we are introducing new technology, hybrid, that show how telecom are important, how technology can help us to do some very great things. And it's also very symbolic because it takes place in the ISEP, as a digital school of engineer. And I'm really happy to have you with us. So my best wishes for this event, and I think we can start. We have a very strict agenda. Thank you very much.
Thank you, Lionel and Philippe. And now, without waiting, we will pass not the floor, but the video to Orange. And first keynote, Michael Trabia, Chief Innovation and Technology Officer at Orange Group.
Hello everyone. When GSM arrived on the market in 1991, I was 15, and I would never have thought at that time that one day every teenager would have a mobile phone in his pocket to communicate with each other and to access the world thanks to internet. As a fact, GSM triggered a real revolution in our lives. GSM was the first digital public mobile phone system. It sparked many innovations. For example, the SIM card, an efficient location and security system, and roaming between operators and countries. These basics, which helped to drive the technology's success, were developed further in following generations and laid the foundation on which our 2G to 5G mobile networks have been built. GSM's development has been remarkable in several ways. Firstly, in the way it foresaw back in the 1980s the potential of the technology in the following decade. By being scalable, it enabled further evolutions years and years later. Secondly, it was designed as a multi-country system, stimulating international cooperation and technological innovation through standardization and the GSM MOU, which is now the GSMA. At Orange, we are very proud to be the followers of those mobile pioneers, and I would like to pay a special tribute to a French engineer named Philippe Dupuis, one of GSM's father, who was working at the Direction Générale des Télécommunications, France Télécom, which is now Orange. I would like to share my thoughts on these 2 points of technological anticipation and international cooperation. Regarding technological anticipation, I firmly believe that the pace of innovation is far from slowing down. Looking at how far we've come over the past 30 years, you might think that everything has been invented and that only marginal gains remain to be made. But this is not the case, both in terms of what technology can do, but also in terms of what people expect from technology. The 5G network is both compatible with previous generation and a brand new network, offering a completely new radio standard, architecture, and protocols. This enables new solutions and possibilities in many business sectors, such as industry, transport, or agriculture, which are using digital technology to improve their operational efficiency. And they will continue to do so more and more as 5G unleashes its full potential. And we are already working on different technologies that will form the basis of 6G. Along with the pace of technology, expectations are also growing rapidly. We must urgently respond to the climate crisis, and mobile networks, and indeed telecom networks in general, play a role in this. Not only Orange is fully committed to reducing the environmental impact and energy consumption of digital technology, for example by pushing and implementing energy efficiency features such as sleep mode or beamforming, but we also drive innovation on green tech solutions for eco-responsible cities, mobility and industry, leveraging not only 5G, but also edge computing, IoT and artificial intelligence. The second point is that I believe multi-country cooperation has laid the foundations for GSM success. This continues today in terms of meeting roaming and interoperability needs and in generating economies of scale. The deployment and rapid adoption of 4G and now 5G have been greatly helped by the economies of scales generated through a global system. Let's not abandon this great achievement and fight any risk of fragmentation of the telecommunication systems, which would be detrimental to the smooth running of digital communication at a global level. For all these reasons, I am thrilled to mark the success of GSM as it celebrates its 30th anniversary. As a pioneering technology in many areas, we must now continue to build on its initial principles to further simplify and enhance our daily lives, our businesses, and our societies.
Orange.
Yeah. Thank you very much to Michael Trabia, and now we will listen and look at Tommy Wito presentation, President Mobile Networks at Nokia. Please.
Bonjour, je m'appelle Tommy Wito et je suis désolé mais je ne parle pas bien français. I have the privilege to speak with you regarding building technology leadership in Europe in mobile communications. And it's a privilege because I only joined this industry in 1996 at Nokia, and I know that many of you have been creating GSM, working for companies like Matra, Alcatel, Teletra and Orbitel. If we go down the memory lane, we can find this picture from Helsinki, Finland, from the switching room of Helsinki Telephone Company some 30 years ago. And of course, many people claim to have made the first GSM call ever. This is the internal call before the press event, where we can see on the right-hand side Mr. Kurt Nordman, the president and CEO of Helsinki Telephone Company, making his first GSM call for sure. If you count from the right, the third person is one account manager of Nokia for Helsinki Telephone Company called Pekka Lundmark, who is today our Chief Executive Officer at Nokia. Now, it's fair to say, fast forward, that today in 5G, we are still in the early stages of 5G. If you look at even some of the leading markets in the world in mobile communications, like South Korea, for instance, or China, we can see that 5G mobile subscription penetration is only some 30%. But what is also remarkable is that in United States, but also in leading European countries, the penetration of 5G subscriptions is still typically only 5 to 10%, so we still have way to go. If we then look at the journey from 5G to 6G, this 10-year journey before we introduced the first 6G networks, we can of course see the different waves or phases where we started with the extreme mobile broadband, ever faster data speeds. Then with 3GPP release 16, we will be introducing better IoT capabilities, ultra-reliable low-latency communications, and then there will be RedCap for what we used to call eMTC. There would be wider ecosystem expansion, and then 5G advanced with many more use cases or improvements in speeds, coverage, Internet of Things capabilities, etc. Now, what is very important to me is that we help European enterprise to make use of the IoT capabilities of 5G technology, because in 5G we designed Internet of Things into the system architecture from the outset, as opposed to 4G where it was only an add-on in terms of narrowband IoT and LTM. Because if we don't do that in Europe, then I would be afraid, and I don't think this is going to happen, but I'm afraid that Europe would become the outdoor museum for American, South Korean and Chinese tourists. So we have some work to be done here. Now, if we look back to the history and ask ourselves, what can history teach us in terms of lessons? We can think about different success factors of previous mobile generations. One can say, and there can be many interpretations of this, but one can say that the success of GSM in 2G phase was that it was a global standard with open interfaces, enabling the scale, competition, many suppliers, innovation. Coincidentally, there was also deregulation so that the old monopolies, the PTTs, would no longer be the only operators. There would be a second, third and fourth operator. Devices became more affordable, and the rest is history. Huge success. One can argue that maybe 3G or UMTS was not such a great success in terms of the incremental impact on humankind and consumers and business. Yes, certainly we put the internet in the pocket with faster data speeds. That was very important, especially with HSDPA and HSUPA, or HSPA for short. Then in 4G LTE, we flattened the architecture. It was a big step. We got rid of the base station controller, radio network controller. Base stations became more intelligent. It was all IP, no more circuit switching, no more ATM. It was all IP architecture. We got new device paradigms like touch screens and better usability and new business models. We had the app stores. We had different types of packaging and tariffing the service and content bundling. So now, if we think about what could be the learnings from history for 6G and for making Europe great again, in wireless, I mean. One certainly is vision and ambition, because if we think about the success of GSM, there was a very ambitious vision for the future, what we all wanted to make happen as an industry. It was important that we create something fundamentally new, not just incrementally, not just evolutionary, but revolutionary. Openness was very important. Open interfaces, competition, scale. And this is something that we should try and protect and try and maintain, if protecting is even the right word when we talk about openness. Symmetry here is also important. I hope that in this geopolitical situation and how the world is now evolving, that we could still maintain the symmetry, having a global reach for a standard and for an ecosystem. But if there are forces who do not want to make it symmetrical, then of course we have to act upon that to make sure that Europe can thrive in the world of the future. And then third, collaboration and Team Europe. One of the big success factors here was, when we think about especially GSM, that there was this collaboration between academia, academics, professors, technology institutes, operators, equipment makers, chip makers. There was this joint work and collaboration, because none of us can be everything, but together we can certainly be everything and more. Thank you very much. Merci beaucoup. À bientôt.
Thank you very much also to Tommy Wito for this speech, and we can see that Michael Trabia and Tommy Wito have given us as introduction very inspiring speeches, and also that match the spirit of this conference, which is not only to celebrate the 30th anniversary of the first GSM call that was already done in July with a special issue of Etsy newsletter, and also at Mobile World Congress in Barcelona with Mats Grandritz mentioning that in his also introductory speech, but also to draw the lessons. And as Tommy Wito said, what can we draw for the present and the future from this GSM success of this European and worldwide collaboration? And I think also GSMA and NGMN will relate us this evening of this worldwide cooperation and globalization. Now I call our speakers, Alain Maloberti, who Alain Maloberti, who was also in our organization team. Then we have Didier Berthoumieux. Then we have Stéphanie Lynch-Habib. And then Lionel Trojman. So we have also in distance our four other speakers, Luis Jorge Romero, Philippe Carrier, Bernard Barani, and Anita Döhler. As you see, a very bright panel. So we will begin, so please sit down, dear colleagues, and we will begin with a presentation from Alain Maloberti. I precise that Alain is a former chairman of Etsy SMG, STC, SMG2 Standardization Group at the GSM Origins, and also a former executive vice president, Orange Networks. Alain, the floor is yours.
Thank you. So, good afternoon, ladies and gentlemen. So, as we all know by now, about 30 years ago, on July the 1st, 1991, in Helsinki was demonstrated the first live call of a new mobile system, a digital system called GSM, Global System for Mobile Communications. It was not anticipated at this time that this system would, together with its evolutions, become the world standard and would be the seed of an explosion of the mobile industry that, if we measure it by the number of mobile subscribers, saw between 1991 and 2020 a 5,000-fold increase to more than 8 billion mobile subscriptions. The GSMA Association estimates also that mobile industry contributed directly or indirectly about 5% of the world GDP in 2020. So at a time where there are a lot of thoughts about launching new European projects, we can come back on the design of this system to see why it was so successful. 10 years before, in 1981, mobile telephony was everywhere in a poor shape. The systems were non-cellular, meaning poor capacity and poor quality of service. The Nordic countries were just launching the first cellular system, NMT, Nordic Mobile Telephone. The systems, although based on the same principle, which was frequency modulation, were all different and generally produced by the local telecom supplier, and of course incompatible between the different countries. Overall, this service was associated with luxury. In France, I mean, it was custom to joke about Philippe Bouvard and his Rolls-Royce and his radio telephone in the Rolls-Royce. In 1979, the World Administrative Radio Conference, the ITU body that assigns frequency bands to various services, had identified a new band, 890 to 960 megahertz, for terrestrial land mobile services. CPT, the European body governing the use of frequencies, but also at that time the telecom standards in Europe, thought that it was a good opportunity to use this band for a mobile system which could be common to all countries. And based on the model of the Nordic countries that had with NMT a common system, the vision of CPT was all customers should be able to use their mobile phones to make or receive call wherever in Europe. On top of providing a common service, this vision had also another consequence: establish a European market that would allow lower costs. The customer would therefore have two benefits: those lower costs and the better service available throughout the continent. The fact that there are end-user benefits were essential because the result would ultimately be aimed at the end customer who needed incentives to adopt it. And to launch this vision, CPT took two steps. Firstly, it decided to set aside this new frequency band for a pan-European system. And secondly, it established an ad hoc group, so-called Groupe Spécial Mobile, to define the standard to be used for this common system. This group was chaired by Thomas Haug from Sweden and held its first meeting in Stockholm in December 1982. The idea was not necessarily to keep all the band free for 10 years, waiting for the pan-European system, but to keep at least part of it, allowing the countries in need to use the rest of it for so-called interim system. But the GSM group did not work on interim system, but concentrated on the future pan-European system. The task was huge. Because every existing system were all provided by national suppliers, it was almost impossible to agree on one existing system. The competition between suppliers turning potentially in competition between countries and causing a political mess. Likewise, picking features from all the systems in order to make everyone happy would have led to something very complex and probably worse than many of the existing systems. The success of the pan-European system would therefore be doomed from the origin. The idea that was in the back of the mind of many people was to go for something completely different and have a clear step revolution in the technology, a digital system. Mobile digital systems existed already in the military field, but their cost was not appropriate for a mass market service. So the question was, is it possible to design a mobile digital system cheap enough to be suitable for the mass market and better in terms of costs and performance than the existing analog cellular systems? The main efforts in the 5 first years were devoted to answer this question, and it was not until 1987 that it was finally answered. How could it be done? The main lever was innovation. All the players launched projects around speech coding, modulation, error correction, propagation, multiple access, signaling, etc. for mobile digital radio systems in order to assess the constraints and elaborate and compare solutions. We can mention the project named Marathon, launched in 1982 in CNET, the research center of France Télécom. The competitive industry project, launched jointly by France and Germany, and the similar project in the Nordic countries with their national suppliers. And this allowed notably to involve industry players which were not directly represented in the CPT discussions. All the players had intense discussions and exchanges to collaborate or exchange their results, either via organized projects, like the European COST 207 project, or via conferences, notably the series of DMR conferences launched in 1985 by Nordic countries. These points may seem anecdotal or minor, but all those exchanges contributed to the progress of solutions and made so that digital mobile radio became at that time a hot topic for R&D in Europe. The second factor was commitment. Keeping the timescales was essential. Otherwise, as interim systems were launched or scheduled in the 900 MHz band in different countries, for instance UK, Italy or the Nordic countries, there was a risk that if subscriber demand was there, they would eat up all the band. The risk was such that at that time there was a certain skepticism about the success of the group to arrive at a solution in a timely manner. And last but not least, cooperation between the people involved. Following the innovation activities, a series of lab and field tests were organized by the GSM group between October 1986 and January 1987 in CNET in Paris to compare 9 different digital prototypes provided by players across Europe. Those results were reviewed by the GSM group in February 1987 in Madeira, and the first outcome was that the tests were showing that a digital system could indeed produce a better performance on all criteria than the existing analog systems. The group decided therefore that the pan-European system would be digital. But for the selection of the type of digital system itself, the political aspects unfortunately entered the game. Whereas all the members of the group were favoring narrowband TDMA as a technology, a supplier present in France and Germany pushed politically so that France and Germany favor the adoption of another technology, wideband TDMA, which was not acceptable to other delegations. And so it was a deadlock. Fortunately, the cohesion and collaboration of all the members of the GSM group and the momentum of the work in favor of narrowband TDMA convinced that supplier that wideband TDMA had no chance to be selected and that it would be better to contribute to the finalization of a narrowband TDMA solution. This agreement was achieved in May 1987 and narrowband TDMA officially selected in June 1987 during a GSM meeting in Brussels. This was really the turning point. The skeptical environment saw that the end of the process was within reach, but a lot of work remained to be done. Finalize the spec, which was still a big work, because to ensure that a mobile station is able to communicate on any network, the specification must be 100% complete and accurate, and also settle all the industrial, regulatory, and business matters to ensure it would be implemented in the different countries and allow a launch.
2 minutes.
On June 26, 1987, the European Commission issued both a recommendation asking administrations to open a pan-European mobile service based on the GSM specs by 1991 and a directive mandating to keep a portion of the 900 MHz band free for this purpose. This directive allowed also the European Commission to finance some of the tasks yet to fulfill, notably those linked with type approval specification. The task was still huge and the timescale was tight. It was made possible by the signature of an MOU between 17 signatories representing 13 countries in order to implement the services by mid-1991. On top of the commitment itself, this group of signatories undertook the necessary tasks that were not part of the specification, ensuring timely availability of network equipment and devices, ensuring availability of type approval testing equipment, allowing data exchanges for roaming, distributing keys for the security algorithm, and so on. And so once the main roadblock passed in 1987, all this allowed, thanks to the commitment and cooperation of all the entities concerned, aligned towards a single goal to complete the spec in 1988 and to perform this first live call in 1991. This was the beginning of another story, the mobile industry explosion. So it was due to the success of a European project, specify and roll out a completely new system that would improve quality of service to the customer, benefit from an economy of scale and from the technological progress to lower costs and allow cheaper and smaller devices in a virtuous circle. As I tried to explain, this was made possible despite the skepticism of many by a mix of vision of the future, commitment to the implementation, huge innovation effort, and perfect cooperation between all the people and entities involved. Beyond remembering the circumstances, some of those success factors could possibly be reused for other European projects to be as successful as the GSM project has been. This is all the wish that we can have. Thank you very much.
Thank you very much, Alain, for this story of a technical European cooperation. So I will ask now Marc-Antoine Dupuis for a short presentation on what Thomas Haug could have presented to us. And Marc-Antoine of our organization team, please let's also precise that Marc-Antoine is the son of Philippe Dupuis, Philippe who had been mentioned there. And Marc-Antoine will rapidly mention the role of Thomas Haug and the positions taken by him.
Thank you, Jean-Pierre. First of all, well, it's a great honor for me to speak here. I will speak, as Jean-Pierre mentioned, about who is Thomas Haug and what was the relationship between the European institution back in the 80s and the GSM initiative. So Thomas Haug is a Swedish man. He's 93 years old, and he's an electrical engineer who graduated in 1952. Sorry. And he worked for the Ericsson Group in Sweden and Westinghouse in the United States, mainly on radio projects. From 1966, he joined the Swedish Board of Telecommunication, the Postal Administration of Sweden, and he co-leaded the joint Nordic project for mobile com. This project, also known as NMT, Nordic Mobile Telephone, was a 1G analog system that entered in service in 1980. After that, Thomas was appointed as chairman of the steering committee of the GSM Standardization Group for 11 years, from 1981 until 1992. His main contribution were, well, the first one, which he said, is to be able to keep the ship afloat in turbulent waters. And there has been turbulent waters during the GSM first 10 years. And his also personal contribution was to keep, for the implementation of the adoption of the SIM card and the SMS. For all these contribution, he was awarded by the American Association of Electrical Engineers and the Royal Society of Edinburgh, the James Clerk Maxwell Medal in 2018. So you can see he has an impressive curriculum. Not only was he co-leading the NMT 1G system, but he was also the first chairman of the GSM standardization group for the first 10 years. Yes, following slide. So now regarding the relationship between the European institution called at that time in the 80s the Commission of the European Communities and the GSM initiative, we can distinguish two periods of times, before 1987 and after 1987. The year 1987 is considered in the GSM history as a pivotal year. Things changed that year. Before, what we can say about before 1987, the attitude of the European Commission was more as a neutral observer. They were thinking, maybe not officially always, well, what your job is interesting, but good luck. What was the situation? 1G system was working okay. We had the system tax in the UK, we had the NMT in the Nordic countries, and it was working. And also, it was the beginning of the US mobile satellite communication that was very promising. And many people thought we didn't need another system. The mobile satellite communication could be the solution. And also, many people thought the GSM would fail, because it was too ambitious technically, but also politically. There was also a great lack of confidence in the ability of the postal administration and also in the conference of the postal telecommunication administration to deliver a workable solution on time. After 1987, and during 1987, the things changed radically, and the role of the European institution became very crucial and very positive. We could resume it at, okay, we believe in it, and let's look at 1991. What was the situation? Well, at that time, after the mid-80s, 1G, the 1G systems, were showing real limits in the number, in its capacity in handling many users in the same area. So going digital was beginning to make sense. Also, the CEPT, the conference of the postal administration area, was much wider than the EC, and the EC was also much stronger politically with its influence. And also, the technical feasibility was starting to be shown. And an important moment happened is during the 1986 European Council in London under the UK presidency. In the final report, the final document of the conference, 3.5 lines were added regarding a pan-European digital cellular radio system. It's very well drafted 3 lines that was saying almost everything about the commitment in doing the in making the standard, and also commitment by the postal administration and the telecoms to commit to put in service in their countries by the early 90s a system. So we could say that also the role, that the Commission had was also to draft a directive in June 1987, so that countries would be officially reserving common frequency bands, not only in countries that didn't have any system, but also in countries that already had a 1G system, and also for the mutual recognition of type approval of mobile terminals, and also their free circulation within Europe. The role was also in financing of resources in the ETSI project team, notably for type approval specifications. So we can see the role was extremely crucial after 1987. Thank you very much for listening to me.
Thank you very much, Marc-Antoine, for this insight of a GSM history, complementary to what was said also by Alain, and also on Thomas Hoog's role. We'll call now Didier Berthoumieux. Didier has not a precise presentation, but he will emphasize on some aspects of Tommy Wito's presentation.
Thank you. Good night, everybody. Do you hear me? Yes, I will comment mainly on the last slide of Tommy Wito's presentation with, if you remember this slide with 3 points: vision and ambition, openness and symmetry, and European teams. And both from a historical aspect of GSM and what we can expect in the future. Vision, when we speak about visionary people, we see Steve Jobs inventing the iPhone, and this is not the kind of vision we had in GSM. The kind of vision we had in GSM was how to adapt to an existing situation, and the existing situation, as Alain remembered us, was that in the mid-80s, the situation of the German and French analog systems were very late. And so the idea was to leverage a weakness, in fact, that we had in France and Germany, and to leapfrog to the next step of technology evolution. And the idea that we can keep in mind for the future is that it is not because we are weak at some point on one domain that you cannot succeed at the next step of the technology evolution. Of course, to succeed, you don't need a weakness only, you need also some visionary people. But this kind of visionary people that you need is people who understand the technology evolution in the different domains, who can make the right bets. At that time, it was not abused to decide that the digital systems would be successful. It was not admitted at all by many people that digital system could improve the spectrum efficiency of analog systems. It was not accepted that a voice codec implemented on a single chip was feasible with a good voice quality compared to the frequency modulation that we had. So we had to make bets, and all those technology evolution were chosen by the GSM teams, including some quite innovative choice like the SIM card. The SIM card was a technology bet which triggered not only a technology security improvement, but it also triggered some change in business models, allowing, for example, service providers, and so the business split between different actors linked with the deregulation which was taking place. But we were in a completely new and moving environment, and having people who understand the possible of the technology evolutions was this kind of visionary that we need. And I think this is also true for the next evolutions of 5G and 6G. There was also some bets on the usage. When you design a new system for the next 10 years, you need to imagine the new usage, but you make mistakes. Nobody imagined that in the mid-80s that we would have some small devices in the pocket. Mobile phone was something installed in the car mainly. When we designed 3G, the 3G was designed with the main use case, which was video telephony 64 kilobit circuit, which did not find its market, but it was really the heart of the design of 3G. And the iPhone was invented only 5 years after 3G. But we need to make bets on new usage, and for the next generation, we are also doing these kind of bets. We cannot succeed on all aspects, but this is how the high tech is evolving. On the vision aspect, which is necessary for the next step, we need to understand and we need to include in our thinking for 5 and 6G the evolution of the semiconductor industry, the Moore's law, of course, but also the huge progress of radio frequency electronics in high frequencies. All the innovations that we see in 5G and which will continue in 6G is all the antenna arrays technologies which are completely new and which were completely unexpected 10 years ago. We need to invent the new usage, and you have seen a lot of communication on 5G and now on 6G, on the future new usage around the IoT, around the factory automation, around the fact that we expect that much more machines will be connected than human beings. So the network will be mainly in the future to connect machines more than human beings. We see also some change in business models. We see in some part of the world some private companies acquiring spectrum, which is new. All this was done in at the time of GSM to implement the business vision of a single market in Europe. And how this was done? This was done by creating a new ecosystem, which was completely new at that time. The ecosystem that we know today in 3GPP is very different from what was the CPT at the time all those GSM bets were taken. We had a top-down approach in CPT, driven by operators which were mainly monopoly at the time. And we can say that the main GSM concept were created mainly by operators and monopoly PTTs at that time. We have moved from this to a situation where we have a completely distributed network of decision makers between operators, between network vendors, between device vendors, between chipset vendors, and now with the service-based architecture of 5G with web-scaler, which are coming into the game together with us. And it's a strange animal to drive the communication system. We can say wireless, but in fact it is now including the fixed network as the core network of 5G is also doing the fixed access as well as the mobile access. And this organization, which is the 3GPP inherited from the GSM and the HC, has succeeded to build a win-win way of working between participants, where no participants completely master the whole chain between the device, the network, the applications. And everybody is investing a huge amount of research and capabilities to contribute to this standard. So we believe in open system, and this was the message of Tommy. Open system means that we split a complex problem, a complex issue of telecommunication networks into small pieces where many people can innovate and contribute to each piece without having to master the whole thing. And this is the way standard triggers innovation. We want it to remain global, and it is not obvious that it will remain global. First, it was not global at the beginning. It was designed as a global system, but it was not global. GSM had competitors in the US mainly, but not only in the US. And in fact, we had to wait for 4G to unify the world with 3GPP2 joining the 3GPP ecosystem. We have seen recently some tentative of fragmentation. 1 minute. We have seen some tentative fragmentation from China in 3G, 4G, from India in 5G recently. Those tentatives have failed for the moment. We see currently a tentative of internet fragmentation from some big countries in the eastern part of the world. We believe that we need to maintain this system global, and sometimes we hear, for example, in HC, HC is, for historical reason, the home of 3GPP. And we can say that in 3GPP world, the center of the world is in Europe, where the economic weight of Europe is not anymore the dominant power. And we need to keep this advantage that we have in Europe of having HC as the home of 3GPP. When we hear sometimes some voice saying that we have too many non-European partners who are influential in HC, we need to be very cautious with that, because if we want to gain competition as compared to other parts of the world, we need to invest and to invest more and not to block anything. If we block, we may lose the advantage that we have built in Europe for historical reason, thanks to this GSM adventure. I think I have to stop here. Thank you.
Thank you very much, Didier. And just an anecdote, perhaps you will correct me or not, but I have read that what is the mobile phone the most sold in the world in the mobile phone history? And I've read that it's a Nokia 1100, a GSM mobile phone launched in 2003, and that was shipped at 250 million units. So just so well done, Nokia. Well done, Nokia. And this was a good transition, Didier, with your last words to Etsy. And I now giving the floor to my colleague Luis Jorge Romero, Director General of Etsy. And Luis, I will just remind what your words in the editorial of your special issue Enjoy Mag in July for GSM 30th anniversary. You told Etsy, this Etsy edition pays tribute to the big bang that GSM brought about in ICT. So please, Luis, the floor is yours. Are you on mute? Are you on mute, Luis? Ah, fine, fine.
Okay. Can you hear me now?
Fine, fine, fine.
So I was saying that thanks a lot for having us here today. Etsy 10 minutes to talk about GSM. Well, 10 years maybe we need, but I try to summarize it in 10 minutes. And I think speakers before me have already pointed at how relevant and important GSM has been and how we made it happen and how we started putting Etsy together. And I think I would like to stress now the relevance that cooperation has had in the creation of GSM, but beyond that, in the society we have now and in the ecosystem we have been able to build all together. We can go to the next slide, please. Yeah. Yeah, it's now on the screen. I see it cut all over, but I would like to point, thank you, because you were pointing at our Enjoy magazine, and indeed we paid tribute to this 30th anniversary of the first call being made in July. And it was actually very good for us to come back and remember where we come from. I think it's very important to know our history. And we were listening before what the first generation was and how we were looking at the second generation. And I think we should pay tribute to all these, let's call them principles that were embedded and put together when GSM was built, and that we give them for granted today. But in fact, it was not that easy when they came and when they were put together. Somebody was saying before that it was a very ambitious project, and indeed it was. Starting by this principle of modular design with open interfaces, which allow this multi-vendor interoperability. This is key in today's system, and nobody would even think of a closed system being bought to a single vendor. How we made the user ID independent from the device, and together with the SIM card. That was also a huge step forward that has enabled zillions of new opportunities in the business. Security by design, maybe we should remember that with the first generation systems, there was a huge problem with fraud and security, and eavesdropping was very easy. So GSM brought this very relevant on security. I think it was the first system where we didn't just think of voice communications. It was not just simple phone, it was much more. And this has been evolving throughout the generations. And then, it's been mentioned before, but this self-assessment of conformity that was so needed to spread the market and to speed up the availability of technology in the marketplace was fundamental and has given birth, and this was a European approach to what we had, a global and very ambitious system. But all together couldn't have happened without this principle of cooperation and consensus building among everybody. If we can go to the next slide, please. Because this is what really cemented what GSM was and what was bringing to the marketplace. Can we go to the next slide, please? Thank you. And here, I think Etsy played a very relevant role, because Etsy was put together when GSM was becoming a reality. So we were born in 1998, and we heard before that 1987 was the kind of the tipping point for GSM. And in fact, having Etsy enabled that we could have a platform where manufacturers, operators, governments, academia, everybody were really coming together and working together with, and that's very important, with a mood to cooperate and pull together for the public good. This spirit, this environment could probably have not happened if the situation hadn't allowed for that. And indeed, it was a spirit of openness and balance of interests. Everybody was doing the best for everybody. For this, it's important that the platform allowed the right processes and methods to permit all this cooperation, and to allow that the system kept evolving. And it was not just a one-off, but it had to be something that evolved with times. And indeed, to all this to materialize, we needed to have a strong team that supported the real experts to develop that work, and that was put inside of Etsy. Next slide, please. So definitely, and it's been said by Didier right before, this is the made in Europe for global use. In the 90s, we saw how GSM, because of this cooperation, because of this pulling together, all we were able to evolve the specifications from the launching until this third generation that Didier was also pointing at. As we went by, we in Etsy kept on believing in openness. Our membership was already very broad. We were seeing how different initiatives were happening all over the world, and we really needed to start working and cooperating with our peers in other regions in the world. And I love this African proverb that says that if you want to go fast, go alone. If you want to go far, go together. And we wanted to go very far, so we started kind of conceiving what 3GPP was to be. So what we called third generation partnership project. When we're looking at the third generation, we should do what GSM had enabled, and based on these principles, we should invite the rest of the world to the party. And we were really generous because there was a huge advance in UMTS specifications in Etsy at the time. And we were ready to put those to scrutiny and seek those into the new project, and also to propose the team that could support that this project could evolve and advance. Can we go to the next slide, please? And here, we, as Didier said, we created this, if I may say, monster that started as a project that is, okay, we'll start a project and the project will die. Well, it's more than 20 years since. And in partnership, as you see, with all of our peers. So we have our peers from Japan, from the US, from China, from India, and from South Korea. And we have seen how the different Gs have been growing and been nurtured in this great 3GPP project. Didier was mentioning it. ETS is very fundamental to this project, and the nurturing from Europe to 3GPP is fundamental. Many companies working together, and we are able to export Europe's principles, Europe's willingness, Europe's needs into the project that then gets global. I think that's a great contribution that we shouldn't miss and that we should keep on nurturing. And next, last slide, please. And I think we need to keep this. I think we need to keep it up and nurture it. We have started with something which is great, that has established some very, very solid foundations. We shouldn't neglect what we have achieved, and we should and we heard it in Tommy Yuito's points at the very beginning of the conference, how when we talk about 6G, we are considering already some of these principles that we put together some 30 years ago when we were talking about GSM. So let's not lose that. Let's be very careful and keep it up. So thank you very much for this, and I look forward to the debate. Thank you.
Thank you very much, Luis, for this inspiring ETSI presentation, and also quite in the timing. Thank you. You will stay, of course, here for the Q&As afterwards. Let's give the floor now to Stephanie Lynch-Habib, who is the Chief Marketing Officer of GSM Association. Stephanie lives in Paris, if I'm not wrong, and shares her time between Paris, London, and other parts of the world. Please, Stephanie.
Bonsoir. Thank you very, very much for, I hope you can hear me okay. C'est un honneur d'être parmi vous. Et I'm going to give a brief presentation that takes into context, I would say, all of the wonderful information that we've heard in the course of the evening, and some of the importance I'll underline. So I think really I'll be talking about the impact that GSM in 1987 and then in 1991 has had on the entire ecosystem. So it's a congratulations to all of you that were so involved in this work starting in 1987. So I guess I'd say who would have thought in 1987 the impact that GSM MOU would have on the mobile ecosystem. I know that the ambitions were fast and far-reaching, but I imagine that we wouldn't imagine what is to come. So I'm talking today, where we've come to. We thought that 10% of the population would own a mobile device, and in fact today, we have 2/3 of the world's population that owns a mobile device, and that is 5.2 billion subscribers worldwide, which is a tremendous achievement, and again, at the core, the cooperation with the GSM in Europe. Also, the mobile ecosystem is very far-reaching, and in 2020, the mobile ecosystem contributed to 5.1% of the world's GDP, and that's equivalent to 3.8 trillion of economic impact, and it also contributes 25 million jobs around the world, the mobile ecosystem. Again, going back to its roots, you should be very proud. And I'll talk about a little bit of the societal and the economic impact in the coming slides, but the ecosystem and the mobile industry, and it's represented by the GSMA. We've got the honor to represent all operators around the world and all of the important players in the mobile ecosystem. We're a very responsible and sustainable association and industry. We committed to the UN Sustainable Development Goals in 2015, and we've made really great strides in the last 6 years, and much, much more to come. I'd like to talk a little bit about current innovation, and again, we've heard some of this before, so perhaps I'll save some time of the 10 minutes. But the trends that the origins of 3G and GSM have created today and propelling into the future, and we've heard this multiple times. This is all around 5G, IoT, and I'll also touch upon the impact of eSIM, which is very interesting. 5G commercialization is well underway. There are 173 commercial networks operating at the end of September 2021. And operators are scaling, and we saw in the earlier presentation from Nokia, at different rates, but operators are scaling their 5G networks and services to reach more consumers and enterprises. And the innovation in that is probably fairly well known, but it's not only 5G, but it's 5G coupled with artificial intelligence, big data, and the cloud that create these use cases for to really propel the next generation of technology forward to make industries more effective, more resilient, more sustainable. Secondly, eSIM technology. You can see by my title, I'm not an engineer, but it provides the remote enabling of SIM services, which is a fantastic rollout, we talked about before, and doesn't have a need for physical SIM cards. It's experiencing a ramped up service rollout by mobile operators. At the end of 2020, at least 175 mobile service providers had launched a commercial eSIM service for smartphones. In fact, all regions, Europe has the highest number of operators that have launched a commercial eSIM service, which I guess isn't a surprise given why we're here tonight. And last but not least, the Internet of Things, which has a staggering 13.4 billion connections today worldwide. It's driving accelerated digital transformation. So it enables companies, cities to create new revenue streams, decrease their cost basis over time, and really help as well with regulatory compliance. So it creates all kinds of efficiencies which are going to be multiplied at scale with 5G. So I talked about the investment that the mobile ecosystem makes in a better future. I would say this is more, this is not just words and slides, this is action. Mobile connectivity is moving the needle on all 17 of the UN Sustainable Development Goals. As an example, at the GSMA, we have our Mobile for Development program. This is a donor-funded program which deploys humanitarian, financial inclusion, and climate projects in low and middle income countries. It's about 12 years old, and we just celebrated being able to touch and impact the lives of more than 126 million people, primarily in low and middle income countries. So those are our donor-funded initiatives, coupled with operators around the world, achieving scale and sustainability. And of course, Europeans, the European Commission has declared the most critical sector in Europe is digital and connectivity, and then of course the mobile industry plays a very, very important role in enabling connectivity, enabling digital transformation. And of course, without mobile connectivity, the resilience that network operators demonstrated during COVID would not have made it would have made it significantly more difficult for people to function during COVID, get connectivity, all of the e-learning, what we're doing today, and that's really thanks to the network infrastructure and investment that was put in place long before COVID. So it's very, very important. I'm sure you will all agree that the regulatory framework in Europe is conducive for future investment, for future deployment of 5G, and that there are financial sustainability measures that encourage that investment, that there are measures that accelerate the shift to 5G, and of course that there are digital advances that are anchored in values and security, and creating a fair, safe, and inclusive digital environment that serves all Europeans. So in conclusion, the open and interoperable nature of GSM technologies, and we've heard this a number of times this evening, has driven a staggering global rollout and the adoption of mobile communication services globally. And it delivers huge benefits to society, to industry, to people. And that is essentially important to continue. So I think just carrying on some of the themes, open standards and cooperation globally and moving forward is critical, and trying to balance some of the fragmentation that's going on worldwide through that demonstration and commitment to cooperation, we believe is also incredibly important going forward. Thank you very much. Thank you for having us tonight and amongst these wonderful speakers. And we really hope that we'll see you also at Mobile World Congress in Barcelona at the end of February. Thank you.
Thank you very much, Stephanie, for this nice speech. Now we turn to our second distant speaker with Philippe Carrier. Philippe is Executive Vice President, Strategy, Research and Technologies at Thales, and will perhaps insist on some security aspects. Philippe, the floor is yours.
Yes, so thanks Jean-Pierre, and first of all, I would say mobile technology remains a topic which is close to my heart given my past life, I would say. But this is also a topic of interest for a company like ours. And this is what I'm going to mention in a few minutes. Because of our involvement directly in mobile technology, but also the impact it has on other industries. So starting with the next slide, this is a topic, 5G, that we look very much in detail. And in particular, you may wonder whether 5G is an evolution or revolution. I would say from a radio standpoint, this is more in the direct line of what we have seen in the previous generation. But if we press the button and we look to the right of the slide, so next slide. But if you look from a network standpoint, this is definitely a revolution. And in particular, as Didier started to mention, the extensive use of virtualization, the fact that we make a use also of cloud technologies, the fact that from a business standpoint, the network slicing function opens new avenues for industries to use their own slice of networks. And then finally, the transformation of the value chain between the different actors. And what role a company like ours, if we go to the next slide, which is, I would say, a defense, an aeronautics space, but also digital security company can play in 5G, is definitely for us a subject of interest. Because the more we look at it, the more there is need for looking at the different angles of cybersecurity for 5G networks. In particular, if we go to the next slide, the fact that we put the network at the center of 5G with an IT approach, with cloud programming, with the transition from proprietary closed systems to open systems, the extensive use of open source architectures leads to obviously a growing, let's say, risk of cybersecurity breaches. And therefore, what can we do? And if we press the button to go on the right part of the slide, obviously, this is very similar to other activities that we have towards the cloud providers. The fact that we now secure largely the cloud of the different GAFAMs and all the large industries. All this from an heritage of secure networks, but also having solutions to deliver for data protection and identity protection. And therefore, what we do is basically the ability to protect the core and the edge of a network, the transport layer, but even more, I would say, protecting identities, protecting data, which is definitely an area in which we are heavily involved. You have the different solutions that we have, but I think it's not really the important point. So cybersecurity means that the more we go, the more I would say the link between telecom operators, the link with infrastructure providers will become stronger with the companies like ours providing data security, cyber security, and security of identities. Maybe a zoom as well, going to the next slide, to one topic we have briefly touched, which is the SIM card. We have mentioned, next slide please. We have mentioned, I would say, all the benefits that SIM has brought in the past. And obviously, Thales now has become an historical player in the SIM industry through the acquisition of Gemalto in 2017. And obviously, this business that we may consider as a mature business is continuously evolving. And as a matter of fact, obviously, what does 5G is to bring more functionalities inside the SIM, like the ability to store the encryption keys, but as well the encryption algorithms, the ability to change the authentication algorithms, and finally to have remote updates over the air directly inside the 5G SIM. This is from a technical standpoint, but if we go to the next slide, I would say that there is even more innovation there, because we started to touch about the evolution towards the SIM, but this is not the only one. Obviously, we start having, in fact, the three kinds, the removable SIM, which will remain for a while, the eSIM, which remain a component that you really put inside the mobile phone. And as a company like ours, what we do is to provide the component, but as well to provide the secured operating system. So somehow it's the same like a removable SIM, but the big difference is the fact that our customers are changing and are becoming the mobile phone manufacturers. And ultimately, we start working on what we call the iSIM, integrated SIM, which means directly working with the chipset vendors. I named one, but there are several of them, where somehow you start, let's say, putting the SIM function inside the secure element of the modem function of the integrated component of a mobile phone. So this is an evolution not only in technology, but also in the go-to-market, and as well in a complete modification of the value chain, not only for us, but as well for the industry. And last but not least, even more interesting is the fact that the ability then to manage the subscriptions, the mobile subscription, is made by secured applications directly in the cloud, which are able to manage the move from the different subscribers or register different subscribers on a dedicated network. And at the end, from the history that we had in Gemalto, we still have the ambition to remain a strong number one in this industry of managing subscriptions. The last word on a topic in which we are involved as well, next slide please, is the fact that we have a space division in Thales, and that we have been heavily involved in 3GPP in the standardization of what we call non-terrestrial networks. And somehow this is, I would say, a fantastic opportunity for the industry. Not that it will replace terrestrial networks, because from a capacity standpoint, from a density standpoint, I mean, and the limited bandwidth that you can have in space, this will not be comparable. But this can be an extremely good, let's say, addition in order to finally make the dream come true, because at the beginning of GSM, we had this vision also of constellations being able to cover the world. And somehow now this day has come where somehow we can combine seamlessly terrestrial networks with a space network, which will have a direct compatibility with a standard normal 5G mobile phone. This is part of 3GPP release 17 as far as I recall. And definitely this is a fantastic opportunity. I would say not only to reach the people which do not have a coverage in mobile, but even more for safety. When I think, for example, of having an horizon connectivity of vehicles for safety reasons, for autonomy reasons, but as well having the capability of selling additional coverage to users whenever they need it, either occasionally or permanently. And therefore, I think this is an opportunity, a new opportunity, along with everything that we have discussed, in order to somehow combine different worlds together, the world of the space and satellites, and the world of terrestrial networks. So that's it for me, and this was bringing somehow a different perspective on a few points of 5G and mobile industry.
Thank you very much, Philippe. And indeed, it brought us some complementary aspects of this GSM and mobile generations adventure. Let's now pass the floor to our third distant speaker, to Anita. So Anita Doller, Chief Executive Officer of NGMN Alliance, Next Generation Mobile Networks. Anita, you recently wrote, "We at NGMN share the vision of global standards for mobile telecommunications, which has been one of our guiding principles since our foundations 15 years ago." So 30 years GSM, 15 years NGMN. Please, the floor is yours, Anita.
Thank you, Jean-Pierre. And it's a great honor to speak today. So I personally spent the entire business life in telecommunication, and I had my first job with an operator in '95. So I know a bit also about the history, but in NGMN, I started as the CEO in 2020. And I thought about to maybe dig a bit into the past as well. But please allow me to also provide a bit an outlook of what we are doing today and what we are going to do in the future as the Next Generation Mobile Networks Alliance. Next slide, please. So NGMN, I don't know if anyone is aware of NGMN. I hope that's the case. So it stands for Next Generation Mobile Networks Alliance. And NGMN was founded back in 2006. And it was, of course, after the foundation of and the initiation of GSM. But digging into the past a bit, it was at a time when actually 3G was not extremely successful in the markets, and where it became extremely important for operators and for the entire ecosystem to look forward. And so the first big step of NGMN was actually in paving the way for the LTE as a standard. Next slide, please. And therefore, I mean, much work has been done, of course, since 2006, but next slide, please. But I would like to emphasize two big important milestones. Next one, please. So that was in 2006, the first requirements document for LTE. And you see that spider diagrams were always very popular. And in 2015, the 5G White Paper 1 issued by NGMN as a very comprehensive requirements document for 5G, and followed by the second white paper on 5G last year. So I think it's fair to say that NGMN has a track record in substantially providing industry-wide guidance on the selection of LTE as a global standard and on paving the way to 5G. And of course, always in very close cooperation with technology vendors and with the SDOs. Next slide, please. So what are we doing today? Next, please. So today in NGMN, we have 80 companies. We are a global organization, and we have operators in NGMN. We have vendors in NGMN, system integrators, service providers, consulting companies, research institutions, and academia. And for me, that's one of the big advantages that we really embrace the entire value chain of the ecosystem. We are an operator-driven alliance. Next slide, please. And in the last year, we went through a significant transformation. What was the trigger for our transformation? We felt that we need to really look on what are the most important topics to be addressed in the industry today and in the future, and what has to be done by our organization to be impactful, meaningful, and to avoid any duplication with other organizations, but to complement each other going forward. So therefore, with the new chairman and with our entire board, we agreed to focus on 3 main important pillars here. They are all equally important, but of course covering different time horizons. And having said that, yes, we have still projects up and running which support 5G's full implementation. So next slide, please. So I would like to dig a bit into the 3 focus pillars, because I believe that's what the important topics are for the industry today. Next one, please. So in operating disaggregated networks. Next one, please. Yeah, thank you. We have a bit of delay here. So disaggregation is a burning topic for the industry today. And how to operate disaggregated networks is something which keeps the CTOs and CTIOs really awake today. And therefore, we said we have to focus on providing impactful support and guidance on how to best operate end-to-end disaggregated networks. So what are we doing in this project? We look at generating end-to-end operating model blueprints, identifying potential gaps, and of course, providing requirements to the industry and to other organizations, and working very close with other organizations like the Oran Alliance, TM Forum, and Linux Foundation. It is clear that the disaggregation of networks requires significant changes at operators, which will touch processes, skills, but also, of course, tools and technology. Next slide, please. So we already delivered the first publication here. Current challenges and needs observed per operators. We will go forward and analyze the industry status and the roadmap, and foreseeing technical and tool evolutions, provide a target picture by network disaggregation. We, of course, consider the requirements and relationships with and by specific industry verticals, and providing operating model options, their pros and cons, and main decision criteria. So everything what we do, of course, is in the pre-competitive area, and it is enabling and providing meaningful support for our operators and vendors and the industry as a whole. Next one, please. So sustainability, green future networks. It's needless to mention, and it was already mentioned also by Stephanie, and I don't want to duplicate due to the short time we have today for the presentations, but it's something which is extremely important for our entire planet. Next one, please. So here, in this year, in 21, we already delivered different publications, sustainability challenges and initiatives in mobile networks. Then the other one was network equipment, eco-design, and end-to-end service footprint. Last week, we issued a publication on network energy efficiency. For me, that's an extremely valuable document as well, because it's like a handbook for operators and vendors, analyzing the different tools and means how to achieve network energy efficiency, and hence is providing great support there. And we plan to publish a fourth one that's on metering and networks. Next one, please. So looking forward for 22, we will continue with the project and the program here, looking again at how can we as an industry reduce the environmental impact. We will continue our work on the use of critical materials. We will look into the end-to-end service footprint calculation. Here, what I found also extremely interesting, our participants in the project discovered that there is an industry shortage of experts on how to calculate the end-to-end service footprint, actually. So also it encompasses the compendium of new business models, like going into circular economy, refurbishment of products. And of course, we will continue with the network energy efficiency phase 2, and we will include also an analysis of energy consumption of disaggregated networks. Next one, please. So now, of course, as our name states, next generation mobile networks, we already started last year to work on 6G. We delivered the first white paper on the drivers and vision for 6G. Next one, please. Next one, please, because that would repeat what I said. And at the moment, we work with the entire membership of NGMN on 6G use cases. We have 40 companies participating in this project. We have very good discussions there, and we plan our first publication on use cases in the first quarter of 22. And then we will start with the end-to-end system requirements, and this will be on time, of course, for any input to the standards development organizations. Next slide, please. So a bit on what we issued as the 6G drivers and vision. What we believe as an operator-driven community, 6G needs to contribute to. It has to contribute to societal and environmental benefits. It has to also provide expanded and differentiated services with a true novel experience over and above what 5G can already deliver. And we also need to consider operational necessities. And this is something which maybe was a shortage in 5G in the previous generations. We really need to have an end-to-end holistic view here to be able to create and deliver enhanced value. Next one, please. So how do we work on the 6G use cases? At the moment, the project is identifying families of use cases based on their contributions. And those families and use cases will be assessed against the established 6G drivers and division. So they have to contribute to those requirements. And the use cases and their families are analyzed and assessed with regards to their differentiation to the fully featured 5G and its applicability and feasibility. So I think that's the main message I wanted to provide today. So as an industry, we need to look forward. We need to address the challenges our industry has today. So that's the disaggregation topic, but also sustainability. So sustainability spans between today and the future. And then, of course, the outlook to 6G. Thank you very much.
Thank you very much, Anita. And of course, you stay with us for one or two questions. Let's give the floor now to Lionel Trochman, Research Director at ISEP. So Lionel, please give us the vision of academics and research on GSM and evolution.
Good evening, ladies and gentlemen. I'm more than honored to be with so many people, impressionant people, compared to what we do from our very humble research lab at ISEP. And I would like also to share with you my presentation, which is academic research, a new reason for technology interest in the European Union. Well, I'm not going to say many new things, just to put in the context, because many things that I'm going to say in this presentation have been already said before. So, well, maybe a duty of memory, reminding where come from our effort on the GSM for global system for mobile communications. Well, I think it's a great cooperation between the European Union and telecom engineers, which throw basically the basis for all the technology we know so far, and based on the telecom standards, cell phone markets, and of course ETCI. We can mention the Bonn Declaration, and it was the beginning of these adventures, which been led then by Thomas Hogg, the GSM, and also Philippe Dupuis, which was also working with him. And for the technical standards, Lamberti and Gianno Destat for the network standards. Well, everything, all these ideas, all these standards converge. One specific year, 1987, the birth of the GSM, also called as pivotal years. And this starts the adventures. So I have more a background on the semiconductors industry, so I will try to focus more my presentation for the context, to give some new piece of information. And by the 1890s, I think all the technology or electronic technology was very cumbersome, focusing on very one applications. And if you were not a geek or technical engineers to know how to use it, was pretty difficult. Well, in early and mid 2000s, we start to see the very beginning of the smartphone, very small tools, which were doing a very great technological operation, even if it was common for many peoples. But it was on one hand, and it was maybe the most sophisticated tools we could build in human history. And this tool, I think, can be divided into 2 chapters. First one, of course, the network part, and for that time, the UMTS network. The other part, the mobile phone itself. And if you set up this mobile phone, you will see inside the chip, the PCB, and so on, until the material perspective. It's a very complex system indeed. And thanks to these these 2 important chapters, let's say, we start to see emerging a new industry on the side of the network, but also on the side of the semiconductor industry. And from that point, I think semiconductor and telecom industry, it's a great marriage of technologies. And they follow all the adventures so far until to now. Well, CMOS technology also rely on a lot of standards and rules, design rules, implementation. You cannot do anything that you want. And it's a little bit what I like to show, so the resonance with the generation of telecom in this slide. So from the 130 nanometers technology, which were mainly employed for the UMTS, device working on the UMTS, and you can see the number of transistors per chip was about 250 millions of transistors. And if you can see from 2004 up to 2022, we go from until technology like the 5 nanometer technology, which have been announced now, which can gather like 150 billions of transistors on the same chip, which is in human population equivalent to 16 Earths. Not only the chip itself, but also the encapsulation. As complicated the chip, you need to be able to use it. And you can see also as the encapsulation chip is very important. So from the very first chip, which is a black box squared, two-dimensional PCB, we derivated on many stacks of chip inside the same blocks. Well, all these interesting perspective is indeed the roots of what we could expect for the next. So the 6G, of course, we heard about it just recently. And technology speaking, well, the fab are already targeting the 3 nanometers and the 20 angstrom, which have been already announced recently, Samsung and TSMC. Well, so to continue my presentation, I would like to focus now based on all these perspective, what I assume as a researcher, a greatest challenge for the telecoms today. Well, first of all, the semiconductors and the networks. As I showed previously, the semiconductors industry and the telecom are working, and at the end, and by end, and it is very important that they keep working this way. We heard recently the problematic of component supply. More recently, with the COP26, also the environmental issues, so low power. But we want also to keep high performance. The IRM, which is the chip for the mobile phone, and specifically, as for the future at least, have to consider all this problematic. That's not easy, and we can see all are working together. The second greatest challenge, I think, is based on the very, very old duality between the internet and the GSM. That start very beginning, you know, and I think we have to wait at least the third generation UMTS and to get included the internet. I believe this duality become today this grow as what we can see as between the GAFAM and the operator, and a good illustration of this, I think, it's eSIM, which is an indication that we are going more and more towards the virtualization. I mean, the SIM as it is, and I understand, is like a contract, you know, an equitable contract between the end users and the operators. We go now for the virtualization. So what's going to happen now? And when we talk about virtualization, behind we have the question of data centers. You know, we need to store this data somewhere, and we also need, and I think one of my previous, the previous presenter talked about this, the security about this, and cyber security more precisely. Well, thought we, the operator are still as a property of the network, the telecom network, which is very great, important advantages, and this is something that, as I heard earlier, is also a lead project that need to evolve for the 6G. And last but not least, not to be victim of its success. This is a number I gathered just yesterday. Well, I heard already similar numbers, so I'm okay with that. Yes, more than 5 billion unique mobile subscribers and 10 billions of mobile phone. I mean, it's huge. It's much more than we could imagine it 30 years ago, I believe. But try to imagine it on the very simple big cities like Paris, you know, with a dense population, people with so many mobile phones on a so small place. I call this a bottleneck dilemma. And in the following slide, I will a short project about this. Well, beyond this, the cyber security, and finally, something which you don't talk too much, but everything which is related to electromagnetic compatibilities. Well, behind the word is the IoT, so interaction between IoT, mobile phones, and all the environment devices which are surrounding people. Well, that's important I mean, issues that I think we can deal with it. And at here, recently, we could have an academic research project promoted by the European Union, where we use a VLC, or visual light communication technology, to handle the problem of, for instance, bottleneck connection for the end user. And this project to show how European Union is important to develop or find solutions is based on a big consortium of a lot of institutions, which ISEP is part of it. And as you can see, this project start to run in by the beginning, mid of 2018. So we are talking the last part of the 5G deployment until 2020. So that's interesting because the VLC were used to develop a technology called Internet of the radio lights, and which use basically the lights from the diode and to transfer very high speed communications and between the different devices. And this successful project, because it has been a success, of course, is now focusing on the 6G generation. And there's a name of the bringing reference learning into radio light network for massive connection, or the CGJ brains, where we intend to introduce intelligence, artificial to handle this problem. So I would like to end my presentation on a very specific perspective view model between Commission, European Commission, academy, and industry. I think the basis of everything is higher education. And higher education need to communicate between different universities. So I call these inter-university centers for research and infrastructure. One hand, we have the research development innovation. On the other hand, the industry. And I think this can be a way to cooperate. On one hand, on the research development, we have the PhD, masters, and publications. Of course, on the other hand, more the professional information and session. And the interaction between the RDI pole and the industry, I think, will be the industry bring funds, facilities, and also propose topic. On the other hand, we will express from the RDI to throw a solution for industry and society modernization and pattern. This model, I think, has to be fueled by states and big institution at European institution. That's it for my presentation. I appreciate a lot your attention, and now we can keep going. Thank you very much.
Thank you very much, Lionel, also for this complementary and quite interesting view from academic institution research. Now I pass the floor to our last speaker and last distant speaker of this conference race of 11 presentations. Wow, you are the last one, Bernard, so it's a difficult task. Bernard Barani is Deputy Head of Unit Future Connectivity Systems at the European Commission, and will draw for us a landscape on European Commission view and also some perspective in the coming years. Please, Bernard, the floor is yours.
Merci Jean-Pierre, j'espère que vous pouvez m'entendre. So many thanks for inviting me today and for this honor, because I feel very humble in the middle of all these distinguished people we have, which have a set history, and it's really something very special. So what I will try to do with this couple of slides is not to go through the success, the importance of mobile communication in society, in the economy. I think this has been amply developed by the previous speakers, and we all are aware of how this technology has impacted the society at large over the last 30 years. I only remember one figure, which is when I joined this mobile communication business in the early 90s. The most optimistic prospect from the analysts and from market studies were for about 40 million users of GSM in Europe. Europe was 12 member states in those days, but that was the range of, let's say, success indicator that was put by the market people. And actually, the reality has been much, much higher than that. So if you move to the next slide, you will see that when we try to look at success factors, next slide, please, if it's possible to move that. I don't know. Doesn't work on your side. Yes, here it goes. When we look at the various generations, I mean, the term cooperation has already been used quite several times to kind of measure or qualify what success is about. I mean, this is certainly something we can all go for, taking into account the various set of support that we have provided to the industry over the various generations. I must say not so much for 2G. 2G was not so much a focus of European research and industrial support. We had the COST project, which was looking into propagation channels and channel modeling, but it was more in those days a kind of scattered support. For instance, we had a lot of support to ARM processors in those days, and we know how low energy mobile processors are important for mobile communications. But then over time, 3G up to 5G these days, we have very much amplified our research efforts. And in 3G, we have, of course, financed the FRAMES project, which has been at the origin of the standard in ETSI in 1999, the so-called landmark decision of ETSI in 1999. Then in 4G, we supported the so-called Wireless World Initiative, led primarily by the vendors, European vendors plus Motorola. And then more recently for 5G, we had this 5G PPP initiative where we believe we have got quite a lot of success in the sense that I think we have been the very early ones to promote 5G for the vertical industries, and we have made quite a lot of effort in that direction. That was our strategy, and I remember in 2015 when we were talking about 5G for the verticals, everybody was almost laughing at us, because in those days eMBB was the only acceptable, let's say, use case for 2015. Maybe not in China, but in the rest of the world, primarily that was the case. Now, when we look at what we did in terms of licensing approaches, this is a little bit different. We have had various type of licensing models over time. And this has kind of reflected the changing political situation, also the changing landscape at the level of the member states. So I will say a few words how this impact has been, starting from the directive in GSM, which was mentioned before. Then the UMTS decision was a little bit more difficult days because we had very, very strong pressure to open the market and not to be seen as a fortress Europe mandating and imposing one single technology. So the UMTS decision had a kind of view that we would have at least one technology developed across all the member states to ensure interoperability across all the member states. But this, of course, had a kind of snowball effect because all the operators deployed that technology. For 4G, I don't think we intervened too much. And now for 5G, we have launched the 5G action plan, which has tried to coordinate member states for their deployment. So these are various type of approaches, and we can say a few words on how impactful they are or they are not. Interesting also to see that at the level of standards, we have moved towards a huge population of standards in the early days to something which is close to one single global standard under 3GPP auspices today for 5G. And of course, this is something we hope we can replicate for 6G. So if you move to the next slide, you will see on this slide some, if you can move to the, sorry. Here okay, that's good, yes. Here we are. So some observations, you can see that in terms of EU introduction of mobile communication networks, it has mapped to a certain extent the licensing approach. And if you look at from 2G to 4G, you can see that the more relaxed we are, the more, the less organized the market is. If we take the 4G, let's say example, for instance, where we didn't have any specific approach to coordinate member states' approaches, we had almost 7 years between the first member state who deployed in 2010 and the last one that who deployed and who assigned frequencies in 2017. So this was really bad in terms of situation. That's really what we wanted to change with the 5G action plan. Even if it was more difficult to mandate a frequency band technology and a standard, we wanted really to try to stimulate member states' coordination. Now, in terms of industry, what is also interesting to note is that over time, we have seen a quite different set of actors penetrating this mobile communication ecosystem. I will not go through the details here, but what we can say is basically kind of expansion and contraction of the industry. On the one hand, the classical players from the telecom side tend to contract and to reduce or to merge or to diminish. Whereas on the other hand, we see a huge number of new players entering the game up to the 5G times today, where we see the verticals, which we don't see or we didn't see so much in 4G. And now, if we look at the IT or the internet industry, we could see them present already in 4G, but for a very specific type of subsystem like OSS, BSS, whilst now we see them populating also the capability of providing network functionalities through disaggregation and open RAN type of approaches that were mentioned before. So if you move to the next slide, please, voila. What we can say, and this is only a snapshot, and most probably you can add many, many more to that list, but if we try to identify what kind of success factors we have had, first of all, something which is obvious, of course, but the fact that the system corresponds to true market expectations, I think 2G and 4G have been very good at that. Mass market mobility and broadband mobile internet, these are really two key aspects which really corresponded to what the market wanted. And for 5G, we have the vertical promise, but probably it's too early to say. What we believe is very important was mentioned before, is the platform openness to unexpected usages. And this is something we have seen very much with 4G, for instance, where actually when 4G was standardized between 2000 and 2010, no one really expected the emergence of the app economy. I mean, the capability that you have to have these apps on your smartphone, which are commanded by widgets. This is something which is not at all planned by the people in 3GPP, and it just came about because the platform was really open enough to make it happen. Regulation market opening, of course, is something that we are very strong believers in the Commission. For instance, the directive ONP on open network provision, we believe, has been very key to stimulate the market through, let's say, putting competition inside. Spectrum is certainly something which is one of the key success factors. We have seen it. 5G has a case in point in there. I mean, when we started 5G discussions, the US were basically nowhere. Europe was very active, Asia was very active. And all of a sudden, Europe came very strongly in the race because they looked at it from a spectrum perspective. They started to assign spectrum, and things became their position became much more prominent, really because of these FCC actions, which were very, very, decisive to initiate the market on the US side. Global standards, of course, is something we are very strong believers, and research and innovation to prepare for them is something that, of course, we support very much. Some speakers before said that it's not granted that for the future we can maintain this global standardization approach. This is something which is part of our worries as well. The industrial landscape evolution, we believe that for the future, it's something where Europe must be very, very careful to be part of these new developing ecosystems. And here again, it's not granted. There are a lot of risks in there. And as we move towards critical networks as critical infrastructures, we believe that the public sector should have a rising importance in the debate and how to stimulate the market, especially towards critical verticals like healthcare or automotive. This is what we are doing at this moment in time with dedicated programs. One very small word about not the users, but the citizen. I mean, on this slide, you see the level of understanding that people have about technology. And you will see that more than half of them are not sure that 5G does not damage their health, does not have an impact on the environment, adverse impact on the environment. And more we see that with the EMF story, we need to prepare for a very strong, let's say, not marketing, but not only marketing, to be able to convince people that radio is not harmful for citizens. This is not only a technological approach, there is a lot of emotion in there, but I think this is really something that we have to prepare for the next generation, especially if we use new frequency bands. Now, moving beyond 5G, it was mentioned already that several players are already looking into the future. That's something we are doing as well. But in the context of the overall policies of the Commission, of course, we now are planning for 6G programs, 6G research, 6G exploratory activities. We have already some things running on that, and we have also published our own white paper on that, or vision paper. But this is part of a wider policy landscape seen from our commissioner, Thierry Breton. So what we believe, because we have pushed very much this notion of strategic autonomy these days, so the willingness for Europe to be a little bit more present on the value chain. One element where we believe is key for Europe to put a lot of emphasis on is semiconductors. I mean, we only produce 4% of the telecom semiconductors of the world, which is extremely low. We have no presence in processors, and a lot of the value chain is lost to the processor. So this is really something where our commissioner is very attentive. And last September, our president announced the so-called CHIP Act, and the CHIP Act will lay the foundation to install foundries and production lines in Europe. So at this moment in time, the plans are for 2 or 3 production lines in Europe. Same for cloud computing, because again, this is a sector we are not very good, and as was said already by several speakers before, telecoms are moving into the cloud. And here again, we have a number of actions which are reflected in the digital decade policy, where we try to stimulate markets to deploy edge nodes and to make these edge kind of services deployable for users. And this is of course connected to the Open RAN stuff, where the telecom functions are implemented in the cloud. Artificial intelligence was mentioned as well. You know that we have a lot of policy actions on that. Cybersecurity is something where at this moment in time we are trying to develop a cybersecurity certification framework for telecom networks. So this is the follow-up of the cybersecurity toolbox. And last but not least, it's not under the direct influence of our commissioner, but very important, and was explained already at length by NGMN, the Green Deal elements that we believe are key as drivers and requirements for future generation. I talked about EMF, but there are plenty of other sustainable development goals that we need to look into to make future connectivity platforms very much fitting requirements from citizens. So it's a heavy agenda ahead of us for the future, especially if we want Europe to stay in the race and to be as successful as it was 30 years ago. And thank you very much, and apologize if I was a little bit too long.
Thank you very much, Bernard. And as I said, do apologize us for not being able to hold a real Q&A session during this heavy and bright program. But nevertheless, with the preparation team, we have prepared some questions, and we'll try to ask one question for each panelist. So I will begin by the two smart ladies, and Stephanie on GSM side. How important is standardization for industrial players, and what role does Europe have to play to establish global standards?
I think it's very important. I mean, we wouldn't be at this celebration of 30 years without the notion of standardization being important, and then adopted, first European leadership and then worldwide. I also think for many subjects, standardization is important, not just for the true underlying technology, but if we just talked about the whole range of subjects, climate, right? I mean, we've got a standardized program at the GSMA that addresses climate and all of the sustainable development goals. And I think that at the pace that technology is moving, and that will move with 5G and 6G and all of the extension to verticals, I don't believe, the GSMA doesn't believe that any one nation or player can do it on their own. So very, very, very important. And it's not an easy position. It's a privileged position the GSMA is in as the global representative for operators in the ecosystem, but it's not always the easiest being the neutral bridge, because we talked about earlier having at times fractured geopolitical situations, fractured points of view, and coming back to Europe in particular, I think that it's fair to say that our key European members are very much aligned on what needs to be talked about at the Commission with Commissioner Breton to make a digital sovereign future. So very important.
Thank you, Stephanie, for this quite precise response. I turn to also, even if it's distant, to Anita Döhler on NGMN. You spoke in your presentation of green as one of your three main axes. So green future networks with reference to network energy efficiency. Operators are working on the reduction of their energy consumption. And at the same time, networks expand and get increasingly disaggregated. How to overcome this dilemma?
Yeah. Thank you for a very good question. So operators already have implemented quite some means and tools, and they look very diligent into the reduction of their energy consumption and to the improvement of energy efficiency and performance in their networks. At the same time, as the forecast predicts, I mean, also because of additional use cases will evolve and the networks will be disaggregated, there is the expected significant general increase in energy consumption. And therefore, it's not enough what we already implemented now as a community and industry. And going forward, as mentioned, we just issued quite a comprehensive paper on network energy efficiency, analyzing different means and tools and their effects on the energy consumption. And we strongly encourage operators and vendors to follow this guidance, but we will need to do more. To continue improving the energy performance as well as reducing the global network's energy consumption, vendors and operators need to put a strong focus and encouraged to put a strong focus on the identified solutions by our project. Going forward and to achieve something on the path to 0 watt at 0 load for future network generations, we also need to consider the use of artificial intelligence techniques to better coordinate and optimize the networks and to have more precise decisions for activating and deactivating sleep modes and shutdown features in the networks, as well as on-demand network dimensioning. And more efforts will be needed, so therefore we will look in our next phase also into additional energy efficiency improvements, and will include also the analysis of energy efficiency and energy consumption in disaggregated networks. In general, I strongly believe that as a global community, we need innovations contributing to the energy performance improvements.
I will turn now to Luis Jorge Romero. And it's a question from my colleague Rémi, and I will give the floor after to Rémi. How can you explain, Luis, the international success of GSM compared to the previous IS-95 CDMA, including in regions such as Asia-Pacific, that were traditionally under a stronger influence from the USA than Europe? What were the key aspects that enabled the rapid adoption and domination?
Well, domination. Well,
or expansion.
Expansion.
Let's remind Luis that still up to date we have still after 30 years we have still 1 billion GSM customers in the world, which is quite impressive. Please, Luis.
Yeah, thank you. In fact, it's a very good question, but if you look at all the principles I was speaking about, what it actually facilitated is, if you compare it with the CDMA system, with the IS-95, you had a system that was very flexible in terms of being able to be deployed with multiple vendors. So that offered the flexibility to the operator that was great. That it was offering some of the features that, particularly with security, that operators were looking for. But all in all, what was most interesting, and I think that's what operators were looking at, is their check. So basically, interoperability allowed economies of scale, not only on the network side, but very, very important on the device side. So all of a sudden, we started seeing so many terminals being put in the hands of the customers with such a huge variety that it was very easy for and very straightforward for operators to decide going to a system that could enable them to grow their market base. And I think this was this was fundamental, and this was something that IS-95 systems had big difficulties in fighting against. So the market basically drove the growth of GSM all over the world, and this was driven by the way in which GSM was built and developed.
I turn to Didier Berthoumieux for Nokia. Rapidly, since the first GSM call 30 years ago, new technology generations have been introduced, each with their own success factors. On the journey from 5G to 6G now, what will it take for Europe to succeed? In brief.
Simple
Last
question.
Okay.
Well, when you're referring to the previous question, I think the strength of 3GPP was the strength of the ecosystem and the quality of internal the competition between the organized competition between the ecosystem members, and the more players you have to compete on a big market, and the stronger you are. So I think that for Europe to succeed, we need public investment, because, as I said, the telecommunication systems are so complex and so big that nobody can master the whole problem. So you need to standardize, to cut it into pieces, and to allocate to different players possibility to innovate and to brainstorm and to develop their own technology. And on 6G, we have already a strong position. We have public funding programs from Europe. We have some national public funding, not in all countries, but for example, Germany has a very strong public funding program for 6G, and we expect that other countries will follow. We have a good basis of actors. We miss, of course, semiconductor. We miss the chipset in Europe. But we can work with external, with non-European players. I think 6G is seen as oriented towards what is usually called the XR and AR, so the augmented reality and all the different applications for the industry around this, for consumers also, but mainly for the industry. We see also 6G highly driven by Industry 4.0 evolutions and factory automations and IoT. I think we have a good basis inside Europe to identify the right use case and to develop in cooperation with academics, industry and operators and public research. We have a good basis to become a leader. It will be a matter of investment, and it will be a matter of political decision taken on time. As was mentioned earlier, the spectrum aspects are decisive also.
Thank you very much, Didier. I will just give the floor rapidly to Rémi. Rémi will ask questions to our remaining speakers, Alain, Lionel, and perhaps Philippe, and also we will have a question also from Dominique. So 2 questions for you.
So, as we are talking about radio networks, of course, the radio access method is one of the keys of the systems. And we remember that a well-known US company advocated very strongly for CDMA in the 80s and in the early 90s. As you recalled us, Alain, GSM finally decided to rely on narrowband TDMA and not on CDMA. So this was the first step of this game. But then for UMTS, WCDMA was chosen. And in the same time, Qualcomm and most of the US players continued with the CDMA radio access. But after a few years, CDMA decreased, and today it is closed from having disappeared. So, can we say that CDMA was a false good idea for technical reasons, or can we say that the IPRs had a bad influence of on its development?
Thank you. I don't think that we can say that the technology is good or bad in absolute, or better or worse than another one in absolute terms. I think that we have to consider also the context in which we can use this technology. So in the term, for mobile radio, the context is first of all the technology. We have seen before that technology is progressing a lot, and so you have to select a technology which you can implement in view of the state of the industry, but also not too much backdated so as to also have a future. It depends also upon what you want to give to the user. So are you aiming at providing voice, or are you aiming at providing also data, and at which speed? Then the solution may be different. Third point of the context, the frequency bands that you have. Can you use a very large frequency band or a small frequency band? And so all this, in fact, would point to you to a different solution. In the case of GSM, for instance, both CDMA, which was selected for 3G, and OFDM, which was selected for 4G, were considered. I mean, in the case of OFDM, it was already used by radio digital broadcasting, for instance, at that time, so it was known. However, we didn't know very much how to do the uplink. In the case of CDMA, it was not. It was a bit difficult to use because the frequency band was rather small. As I have mentioned before, only a part of the 900 MHz band could be used. So, depending on the state of the context, you can have, in fact, different choices. And of course, I have mentioned the technical context, but there is also a non-technical context. I don't know, because I was not part of the choice. Maybe Didier or Eric Ardouin know better than myself whether the IPR point played a role in the selection of OFDM versus CDMA in 4G. But it's clear that it is also a point. I mean, speaking under the control of Philippe Carrier, I know that currently there are discussions, in fact, to standardize cryptographic algorithm, post-quantum cryptographic algorithm to resist, to be robust against the computing power of quantum computers. And the best solution, there is some IPR, and there are some discussion about whether they will be selected or not. So not only in the mobile, but in all the industries, there is this point. I don't know if it was something which was decisive in the framework of the 4G, but I mean, it is possible as well. But again, I think that what is important is the context, technical and non-technical, and then the choices can be different depending on the context.
Thank you, Alain, for this explanation. And I have a question for Bernard Barani. So if we look to one of the success factors for GSM, there was the type approval of the GSM devices, this type approval involving the mutual recognition. And as we know, in the first phase, this was, to say, organized by MOU, by the MOU GSM, today's GSMA. And then at some point in time, the European Commission said, if I summarize, okay, that's fine what you did, but from some point in time, you should apply the European directives. In the meantime, there is an interim period, and then you have to comply to the European directive. And so, in fact, this was a very good way of proceeding, because this was both pragmatic and this helped the type approval. Do you think that in other for other techniques for 6G there should be such approach of first it's pragmatic phase, I would say, and then compliance to the European directives?
Honestly, I don't know what 6G is going to be about at this moment in time. So we will see exactly what it is, what the actors are prepared to make out of 6G. I mean, if I look at 5G at the origin and what 5G is actually in the standards, it's not exactly the same thing. The radio access, for instance, is much less ambitious than what it was originally in the research program and seen by the various actors. Now, to define the way 6G is going to be deployed and to make it a success, for us, what is important is that the conditions that were discussed before, that the ecosystem has to be created. And this is where we have a chance in Europe, is to early enough in the process to create the ecosystems by generating the partnerships with the vertical industries, because thanks God, we still have some industries in Europe with whom we can work and try to make the things together, develop the right standards, develop the right technology, and develop the right use cases. The regulation that goes behind it to enforce one or the other mechanism, to be honest, I think it's too early to say. I just don't know. It's just like if you ask me what kind of frequency bands is going to use. I mean, there are various options today. I don't know what will be successful.
Thank you, Bernard. I will give the floor now to Dominique Balbi, for your question on research of Orange Research, on Orange Research point of view, to Philippe and or Lionel.
Bonsoir tout le monde. Okay, the question is, in your opinion, Lionel, do you think the biggest or major challenges for 5G and 6G are technological or societal?
It was stuck over there. Yeah, okay. Thank you very much for this question. Well, I researcher and working in higher education institution. Of course, for us, it's very important to see what has a need, and specifically the need of the society. From it's important that research has end and useful end, because we are engineer first. And I believe that society is driving its own force, maybe through politics and institutions like European institution. And upon what happens, so we are now in front of environmental problematics, high rate population or demography, and so on. And I think the goal of the engineers in today's society, as it was also before, but I think today it's even more critical, is to bring solutions, to support human society, to build themselves and to be able to keep going. And that's, of course, a very tricky goal. So to answer your question, I think first it's a society, I mean, for the 5 and the 6G, to the 6G, and also the problematic which are around. I think it's first society needs. We have seen many times saying that the 5G it's a revolution. So we are expecting even more maybe from the 6G. And in the second part, technology has to come. So technology is going to be, for, of course, the semiconductor industry. We are now already projecting some technological challenge which have never think about. I mean, again, 20 or 30 years ago, talking about the 3 nanometers or the 20 angstrom in terms of rate of transistor integrated on the same chip. and be able to bring information with so many information to human people. So that is all the challenge we are facing for what the society is expecting from us.
Thank you, Lionel. Thank you, Dominique. The last, sorry for that. The last question in the room will be asked by Philippe Picard. Philippe, a question to another Philippe, Philippe Carrier.
Well, in the old time, the telcos through COPT and ETSI could master the whole end-to-end services like SMS, directory, or security. Today, the telcos will compete with a lot of other competitors in the field of standards, above all Internet world, and service providers like Skype, WhatsApp, and so forth, which don't care with standards and compatible services. So what do you think of the future of end-to-end services and RCS, Rich Communication Services, when the telcos has to compete with this unregulated, well, let's say, GAFAM? Thank you.
Wow. So I think there are obviously different layers because yes, there might be a competition on the end-to-end service. However, the way the networks will evolve will require, let's say, somewhat coordination or optimization between the service layer and the network itself. And we see more and more work that we do directly with the GAFAMs in order to optimize this or that service. My view is that GAFAM will also move towards a certain way of more cooperation with the rest of the industry. Just as an example, I will take the recent announcement that we did. It's not related to the mobile industry, but it is quite interesting, which is how we could, together with Google in that case, but we were with other GAFAMs, make significant modifications in the Google Cloud in order to provide a cloud de confiance, a secured cloud, where we will have the ability to inspect the code of GCP, where we will be able to offer, let's say, immunity to extraterritorial capabilities of some countries, but while benefiting and have a fully secured environment, while offering a full-fledged GCP to customers in France. And in my view, this example, and we may reproduce it in other domains, shows that we are at a point of time where the GAFAMs are accepting, also for business reasons, to change their business model and to change the way they look at the world and implement solutions in coordination with actors like us, but also like telcos, because I think there will always be a need for the service layer and for the telecom network.
Thank you, Philippe. I think due to this time, unfortunately, we cannot have other Q&As, but definitely we will send all the participants some testimonies, some presentations that have been here presented. I will just relay, before going to the cocktail reception for those who are lucky to be here, a testimony from our colleague of IREST Association, Yves Alexandre, who wanted to underline and to stress the very important role played in the early 80s by Jacques Dondou, at this period the Director General of France Telecom and also founder of IREST. So I wanted just to remind that from our colleague Yves Alexandre. I will thank very much on behalf of all the organizing team that you have seen here today, all our speakers. I think it was, as I said, a conference race, but I think we succeeded, and thanks a lot for your bright presentations, even and responses, even in distance or here on stage. This was a first opportunity for us to do this, to organize this hybrid conference, and we hope it has satisfied you. So thanks a lot, and let's go to the cocktail, but once more, a big applaud.